uh, let us continue with what is started last time. I hope you can hear me. Can you just confirm that I'm audible? Hello?
Yes, sir.
And can you see my screen?
Yes, the screen is also visible.
All right, okay. So here are some examples of incompletely specified FSMs. And as you can see, the next state and also the output may be unspecified in any combination. So sometimes the output is specified but the next state is not specified. Sometimes the next state is specified, output is not specified, and sometimes both are left unspecified. Okay. So these are various possibilities. Now there are a few things that okay, it's better to maybe we can just start with the example. So yeah, so we just have so over here let us have these FSMs, and over here let us have this margin table. All right, so when you have an incompletely specified FSM, you can consider the possibility of merging pairs of states. Okay, so so just remember a few things. See, suppose you have three states. All right, now suppose A and B are compatible. All right, and let us say A and C are compatible. All right, now if also B and C are compatible, I mean this can be simply represented in this manner. You can represent it by an edge. A and B are compatible, A and C are compatible, and B and C are compatible. All right. So now this forms what you call a clique. So a clique of a subgraph. So the clique of in the clique of a subgraph, all pairs are compatible. Okay, all pairs are compatible. So if all pairs are compatible, then you can merge all the three states together. So if you want to merge states A, B, and C together, all of them must be pairwise compatible. All right. So that is an important point to note. So first of all, what we check here through the merger table, we check for pairwise compatibility. All right, and then we look for clicks. All right, we look for clicks. Now, so let us see how it goes on. So here we are looking for pairwise compatibility. So all possible pairs, that is represented in this kind of a table. Okay, it's called a merger table. Now let us see the compatibility of A and B. Let us say you want to check whether A and B are compatible. So for A and B to be compatible, as you can see, for A and B to be compatible, so this is their input alphabet. Okay, I1 and I2 are symbols from your input alphabet. So the I1 successor and I2 successor should also be compatible. So if you look at this table for A and B, what you see is that we have, so for A and B to be compatible, we say that, so we have this requirement that they're, the successors, the I1 successor and I2 successor, because in this case, as you can see, the input alphabet has just two symbols, I1 and I2. So here you can see the I1 successor are E and F. So E and F must be compatible. So note that the outputs are compatible. Okay, the outputs are compatible. So when you supply input I1, both A and B have output 0. So they have the potential to be compatible. All right. So but they will be compatible if E and F are compatible and also A and B are compatible. Now, okay, so for input I1, the output is 0 and the transitions are to states E and F respectively. So for A and B to be compatible, you see that E and F must also be compatible. That's what we have written here. Also, if you look at the I2 input, then you need A and B also to be compatible. So that's all right, So for A and B to be compatible, you have, E and F must be compatible and A and B must also be compatible. So this is a self requirement. So that's trivial. All right, that's trivial. But E and F, the compatibility requirement for E and F, that's a non-trivial requirement. So we have, that has been indicated in this table. So these trivial requirements are indicated in this color, purple, I think, or pink, whatever. So the trivial requirements are indicated in this color, and the non-trivial requirements are indicated in black. All right. So in purple we are indicating the trivial requirements. So now I think it will be okay. So let us complete the first column. Okay. So this is compatibility of A and B. Let us look at the compatibility of A and C. So if you look at the compatibility of A and C, so if you look at this one is unspecified. So let us look at the I2 compatibility first. So on I2, you have, A makes a transition to B and C makes a transition to C. So B and C must be compatible. All right. So this is a non-trivial requirement. For A and C to be compatible, B and C must be compatible. Further, now this is an important step. For A and C to be compatible, what you find is that for A, of course, the transition and the output both are specified. But for C, although the transition is specified, the output isn't specified. So in this case, what you have is you have the option to specify the output, okay, favorably. You can specify the output favorably. So what you see is that for A and C to be compatible, you need E and E to be compatible, but with the caveat that the output is conveniently specified. So the output in this case must be specified to 0. Only then this can be compatible. Now you consider the compatibility of A and D. So A and D, as you can see, these are not compatible because on input I1, here the output is 0 and here the output is 1. So they are simply not compatible. So we mark that with a cross. Similarly, A and E are not compatible. You mark that with a cross. A and F. So A and F, for A and F to be compatible, you require E and D to be compatible. Okay, E and D to be compatible. Again, you find that here you have the output which is unspecified. So you have the option to specify the output according to your convenience. So if you want D and E to be compatible, of course the output must be 0, must be specified as 0. Alright, and here of course this one is trivial. You need B and B to be compatible. Alright, now let us look at the next one. Between B and C, okay. So between B and C, if you see, the requirements are that E and F should be compatible. Alright, E and F should be compatible. And also A and, sorry, we are looking at A and C. So A and C. So B and C should also be, sorry, A and C. No, we are looking at B and C. B and C. Okay, so for B and C, E and F should be compatible and A and C should be compatible. That is what is written here. Alright. And then you see that B and D are not compatible. So that is quite evident here. B and D are not compatible. Here you have the output. So although the transitions are to the same state, but the outputs are different. So B and D are not compatible. And here we find is that again B and E are not compatible. B and E are not compatible. So for B and F, as you can see, for B and F you need F and D to be compatible and A and B also to be compatible. So D and F and A and B to be compatible. So now in your notebooks, can you fill up the rest of the table? I think it is important for you to do that. Can you fill up the rest of the table in your notebooks? Don't look at the screen here. Just fill it up on your own. I think you should be able to do that now. So I'll give you a few minutes. So just fill up this table carefully. Have you done it? Yeah? Are you done with that?
Yes, sir.
Okay. So everyone, I hope everyone is doing it. Preet Kumar, have you done it?
Yes, sir.
Preet Kumar?
Yes, sir.
Alright, okay. So this table, I mean, we'll now look at the cancellations, okay? So there are some cancellations. So now what you find is that there are some crosses, right? For example, A and D, B and D, B and D, for example, these are not compatible. Now you find that D and F, D and F, for D and F to be compatible, you require B and D to be compatible, alright? You require B and D to be compatible. But B and D are not compatible, as you can see. So since B and D are not compatible, so F and D couldn't possibly be compatible, right? F and D couldn't possibly be compatible. So we cancel this. You could have put a cross here, okay? Cancel this and you could have put a cross. So D and F are also not compatible simply because B and D couldn't possibly be compatible. And also over here you find that for B and F to be compatible you require D and F to be compatible, but since D and F cannot be compatible, you find that B and F also cannot be compatible. So this way you are able to reduce this table. So this table is reduced to some extent. So you have this merger table, all right, and yeah, so this is the reduced merger table, all right. So here if you look at this part is trivial. So C and E, this entry is trivial. So C and E are compatible. Yeah, so let us see. So C and E are compatible. C and E depends on C and E and yeah, CC. So sorry, I hope I'm using. Oh, this is ME. All right. Oh, sorry, you got to use this table. Sorry. Yeah. So C and E, you find that the dependence is on CC and C. So this is of course you assume that the output of E must be conveniently set to 1, okay, must be conveniently set to 1 for C and E to be compatible. So of course I have marked it with a tick, but there is the underlying requirement that this output has to be conveniently set to 1 for C and E to be compatible. All right. Now this same table can be represented as a graph. Okay, so this is a compatibility graph. This merger table can also be represented as a compatibility graph. So we have a node. We create a node for each. We don't need to create a node where there is a cross. For example, there is no node for AD because those are not compatible anyway. So for the other uh, table entries, for each table entry which is not marked with a cross, we can create a node. All right. Yeah. Just a minute, please. Yeah, okay. So, yeah, so this Marget table can also be represented as a compatibility graph. So this graph indicates the dependencies, okay? It indicates the dependencies. So it's the same information which is represented. So, so I think, so can you construct this graph in the graph for this machine ME from its Marget table? Can you do that? It is so C and E is a standalone node because it doesn't have any other dependency as such. Now A and B depends on E and F, so you show that A and B depends on E and F. So and E and F in turn depends on C and D. So if you see E and F, sorry, E and F, it depends on BC and CD. So this depends on CD. It also depends on BC. So just can you draw the compatibility graph from the Marget table, all of you, in your notebooks? Just do it now. Are you done? Have you constructed this compatibility graph for ME from this Marget table? Yeah? Have you done it? Hello? Yeah, Kaushiki, have you done it?
No, sir, doing.
Yeah, Kaushiki, have you created the compatibility graph from the Marget table?
Doing.
Hello? Can't hear you anyway. You're
Sir,
muted.
doing.
Huh?
I'm doing.
Okay, do it. Yeah. What about others? Sushant Kumar, are you done or are you still doing? Sushant Kumar, are you there? Hello?
Yes, sir, I'm there. Yes, I'm doing.
Have you done it?
I'm trying.
No, do it. If you have a problem, you ask. You should be able to
Yes,
do
sir.
it. It is very simple. It comes directly from the Marget table. So just look, you can just look at the Marget table shown over here and draw this graph. There is nothing more to it. You just look at the entries and you just put a directed edge to these to the nodes corresponding to these entries. For example, the node BC. From the node BC, you'll have an edge to the node AC and another edge to the node EF. It is as simple as that. So it shouldn't take too long to create the compatibility graph from the Marget table. All right. Are all of you, are you done?
Yes, sir.
Yeah, we need to do another exercise. So maybe I'll give you one more. Actually, this is a very creating the compatibility graph from the market table is quite easy. So it should be done by now. All right. Now let us look at another machine. So I over here I've given the compatibility graph for MD. So for MD, why don't you try to create, of course it's possible to create the compatibility graph directly. So why don't you try to create this compatibility graph directly for MD? So let us look at, so AB, let us look at this pairwise. AB, can A and B be compatible? Yeah, please answer as we work on it. What about A and B? Can A and B be compatible? Yes? Please answer.
Yes, sir.
So, Pramit Chandra, what about if you look at the machine MD over here? So states A and B, can they be compatible? Yes? Pramit, are you there? Hello? No response. Saksham Arya, are you there? Saksham Arya? Seti? Seti, are you there?
Yes,
Hello?
sir. I'm trying. Yes, sir.
Okay, so what can you say about the compatibility of states A and B for the machine MD? Should they be compatible? What do you think? Yeah? What do you think? Should they be compatible or not? I'm not getting any answers. Shajal? Shajal, are you there? Hello? Srijan, are you there?
Yes, sir.
So, what do you think about the compatibility of states A and B? Should they be compatible?
Sir, here for each of the inputs, my one output state means next state is not there. So Sir, can I take all the possibilities for that don't care state?
See, when you have those unspecified, then you have some freedom, right? So you have
Yes, sir.
the option to specify them to your convenience, right?
Okay,
You
sir.
have the option to specify them to your convenience. For example, since so on the input symbol I1, both the transition and the output of A are unspecified. So if you want A and B to be compatible, so you always have the option to make the next state of A on I1 compatible to the next state of B. So the easiest way to do that is to choose that, to set that to E itself. And
Yes, sir.
since the output is unspecified, you can set the output to 0.
0.
Okay. So you have the freedom because it is unspecified. So from that point of view, if you look at this graph, so for AB, we have not specified any dependence. We have not specified any dependency. Why? We have not specified any dependence over here because we have the option to set them as required. Now let us consider AC. Alright, if you consider AC, so this part is unspecified. So for A and C to be compatible, you can see that C and F must be compatible. Their outputs are compatible. Alright. So you need F and C to be compatible. So these are unspecified. So you have the freedom to specify them according to your convenience. But F and C must be compatible. So you would expect an edge from AC to CF or FC. So let us see. From AC, do we have AC here? Yeah, AC to CF. So that edge is there. AC to CF, right? AC to CF. Now let us consider A and D. So A and D, also for A and D to be compatible, you require B and E to be compatible. So let us see. For A and D to be compatible, you can see that you need B and E to be compatible. So you are putting an edge here. Alright. You're putting an edge here. So can you complete this graph for MD in this manner? Can you complete this graph, all of you? And when I call out your name, you can post it. So take a picture and post it. So you complete this graph and then I'll call out your name. Then you can post it. So complete this graph for the machine MD. Of course, this we don't have to post it because it is right here, but I'll ask some questions. So are you done? Have you constructed? So just complete the construction, then I'll ask a few questions. If you don't answer, then I'll mark the person as absent because You're expected to participate in the class. So please complete, construct this graph and then all right, okay, let me ask some questions. So all right. Uh, so Abhishek Rajesh. So if you look at this, can you identify a pair which is missing? So there are 6 states, right? So there are 6 states. So you can have, so you find that all possible pairs are not here, right? So can you identify a pair which is missing in MD? Abhishek. Yeah?
Yes, sir.
So why don't you identify a pair which is missing? For the machine MD. Yeah? Are you able to identify a pair that is missing in
No,
this graph?
sir.
Huh? How many possible pairs can exist? How many possible nodes can be there in this compatibility graph? When you have 6 states in the machine, huh?
NC2.
So what will that number be for MD? For MD, what will that number be?
10.
10. What is N? What is N? You say NC2, right? What is N for MD?
5,
Huh?
5, 5.
5. Can
No,
you,
it's, sir.
huh?
It's 9.
9. Can you read out the states? Can you read out? The states of MD. Yeah. Can you read out the states of MD? Hello?
States.
Huh? Can you see the machine MD first of all? Yes or no? Yeah? Abhishek, I am talking to you. Can you see the machine MD or not? Yeah? See, then I'll have to ask all of you to work out and submit. You take the machine ME, work out the compatibility graph and submit. Because if you are not participating in the class, I have to ask you to do that only. Okay. So you look at this FSM, this ME, you work out the compatibility graph of this and submit. I'm setting up an assignment right now. Okay, you do that. What? Take the machine ME and you construct the compatibility graph for ME and submit. If you have any questions, you can ask. Okay, please do that now. All of you submit by 11:15.
So when I'm trying to view the assignment, it says it's forbidden
Sorry?
and I don't have permission.
Sorry?
So when I'm trying to open the assignment, it says it's forbidden and I don't have permission to access it.
No, just a minute. I'm just completing it. I'm nearly done. Yeah, you should be able to do it now. Just see if you can do it now. I've not added any assignment statement, but I think you should be able to. You should be able to see it now. Can you see it now? I've not added any assignment statement as such. So you
I
just
can
have
see
to.
the assignment, but I can't see the anything within.
You can't see what?
I can see the assignment, but there's nothing inside it. It says forbidden.
The submission link. Are you getting or not?
Yeah, submission link is
Yeah,
there.
that's it. You need to submit only. Because I've not put up any assignment statement as such. Assignment statement I'll put up later. But assignment statement I've given you orally. So for the machine AMI, you're supposed to construct such a compatibility graph. You're supposed to construct such a compatibility graph for the FSM AMI and submit. Yeah. So if you have any questions on it, on how to construct the graph, you can ask. No. Hello. Uh-huh. Huh? আমি কোনো অ্যাসাইনমেন্ট স্টেটমেন্ট দিইনি, সাবমিট করতে পারি। সাবমিট আমি করেছি, অ্যাসাইনমেন্ট স্টেটমেন্ট এখন করা হয়নি, সাবমিট করতে। হ্যালো, হ্যালো, ঠিক আছে। Okay, so are you able to do it? Or do you have any questions? There is ample time, so you do for ME and MF also. You construct the compatibility graphs for both ME and MF. Okay. For MF you have got only 5 states, A to E. For ME you have got 6 states, A to F. So you construct the compatibility graphs for both ME and MF and submit.
Sir, but
Excuse me,
now
sir.
we have exam from 11 in another.
Huh?
Now we have
Yes, sir.
exam in another class from 11.
Sir, we also have a class on 11. So, like, could you extend the time?
All right, then you can submit after the exam then. So you have exam till what time?
11 to 12.
So you submit by 12:15. You submit by 12:15. Okay. I'll set it to 12:15.
Okay, sir.
Yeah. All right, then I'm closing it now.